All right, so 2-3 is measures of central tendency, which we're going to focus on mean, median, mode are our measures of central tendency. So you guys have done these before. The first part's going to be quick and easy. And then we're going to get into some more complicated ways that you could calculate mean for different types of data sets. All right, so starting with mean, again, a couple of these things aren't on your handout. If you just want to put it in the margin, that's fine. Remember, formulas, like you see for population mean and sample mean there, are on your purple packet that you have. Does everybody have a purple packet in here? Yes? Okay, just making sure. All right. Okay, so mean is the average. Add them up, divide by how many there are. You guys know how to do that. We're going to see the sigma notation. We've been practicing with that a little bit. Remember, anytime you see that sigma symbol, it looks like a kind of a pointy E. You're just going to total up everything. So when we see sigma and X, X represents the data entries in the set. So sum of X, it's more so, instead of a formula, we want to think of it like a set of instructions. It's telling me add up all the values in the data set. When you see that symbol next to an X. Then, when we calculate population mean versus sample mean, you're going to see two different sets of symbols. If it's a population mean, you're going to see this guy. It kind of looks like a U with a really long tail on the left side. It's mu, is how we say that. And our instructions are sum up all of the X's, so add up all of our values in our data set, and divide by n, where n is the number of data values in the set. If it's population, it will be a capital N. If it's a sample, the formula is actually the same. The instructions are the same. Add up all the values in the data set, divide by how many there are, but the symbols are a little different. The sample mean is an X with a bar over it, so we just say X bar, and then my number of data values is a lowercase n. And again, both of those should be on your purple sheet. If we have a qualitative data set like categories, or titles, or names, or labels, we cannot calculate a mean. It's only for quantitative data. Okay. All right. Then the second one is median. So it's the value that lies in the middle of the data set. You will have one of two situations happen when you calculate a median. Either you're going to have an odd number of data values. If that's the case, the median is the entry in the middle. Just kind of work your way in or count or however you want to do it. If there's an even number of entries in the data set, an even number of values, the median is the mean of the two middle numbers. So you have to find the two numbers that are in the middle and then find the midpoint of those, add them up, divide by 2. So it'll either be a number in the set or the mean of two numbers in the middle of the set. And then finally, mode is the most often occurring number in the set. It's possible that you have no mode if everything occurs the same number of times. It's possible to have two modes if there are two values that occur more than everything else. If we have two modes, it's called a bimodal set. You can have 3 modes or 4 modes. There's a lot of different ways you can do this. So if I look at this quick little dot plot at the bottom here, find the mode of the data set. If it's anything that represents frequencies, it's quick to just find the one that's the tallest, right? So 10 minutes to eat breakfast would be the mode of the data set, the most often occurring data value. Okay? Any questions reviewing mean, median, mode? Yes?
Go back to the mean.
Yes.
Oh. I see it.
All right, so I think this is the first problem on your handout. We're going to find the mean, median, and mode and range that we did before of this data set. And then make sure you're looking at the key. These are all decimals that are represented in this stem and leaf plot. All right, so let's start with, I think mode's probably the quickest one to get. Bless you.
Thank you.
What's the mode? Most often occurring data value. It is.
8.
8, but there's a stem attached to that.
Oh,
That's the leaf.
7.8.
7.8. Agree. Yes. Okay, let's go ahead and find range. Next. What is the largest data value in this set? 9.5 minus the smallest, 4.1, gives me a range of 5.4. Okay. Median is the guy that's in the middle, or the two that are in the middle, the midpoint of those. So if I have something like a stem and leaf plot, I'm just going to cross out pairs of numbers at a time until I get into the middle. So the 1 and the 5, just be careful, make sure you're going from highest to lowest and lowest to highest as you kind of work your way in. So 2 and 0 get crossed out, 7 and 0, 8 and 8, 5 and 8, 6 and 8, and I am left with these two guys in the middle. Okay, and then you can double check this if you want to. There are 6 numbers above those, and there are 6 numbers after those. So that's how I know I'm in the middle. You could always count that at the beginning if you don't want to cross out numbers. So it's between 7.0 and 7.5, which you can probably do that in your head. But the math that we do is we add them up and we divide by 2, and we get 7.25 is the median. Okay, last but not least is the mean. So to get the mean, we are going to sum up all the data values and divide by how many there are. There are 14 in the list here, so we've just got to add them all up. Let's see. I'll do it too. We can make sure we all get the same sum here. All right, I got a sum of 97.3. Yeah, confirming that. All right, divide by 14, I get 6.95 for my mean. Okay. Questions? Calculating those. Okay. Moving on. All right. So you need to do a quick Google search. If you want to grab your phone to do it, or if you want to use your Chromebook, you can, or if you want to share a device with a friend, that's fine too. I need you to do a quick Google search of how many calories are in your favorite fast food item. Whatever that is. It can be a beverage, it can be a meal, it can be a single item, whatever it is. Google the calories.
The what?
The calories. All right, and then I want you to put your number on the board, on the front board in a second here, and then as a class, we're going to calculate mean, median, mode, and range of that data, just to get a little extra practice here. All right, so you guys have your graphing calculators. Let's check these answers with the graphing calculator. So remember, for tests in this class, you will not be allowed to use a graphing calculator. You'll have the basic red ones, but when you do your projects for the class, you will be allowed to use a graphing calculator. So things like this, and when you're doing your homework, especially too, if you feel like you understand a concept, it can make the homework go a little bit faster. All right, so let me load mine up here. Show you how to check it. I'll just leave those there. That's fine for now. Okay, go to stat. It's not stat. There we go. And then just hit enter where it says edit. And then does everybody have an L1 and an L2 in there right now? Yeah? Okay. So we're going to go up to the list name, hit clear, and go back down if you have stuff in there. Okay. Up to the list name, clear, and go back down. If you hit delete, it will get rid of the list name, then that's going to cause a problem later. So make sure it's just clear only that you're using. All right. In list 1, you're going to put your data values. They do not have to be in order. So this is another time-saving hack. Okay. So 497, enter, 420, bless you, 380, 840, 440, 350, 520, 740, 287, and 480. And then as you're typing the last one, or if you hover over the last data value in parentheses, it'll have a 10 there, so you can make sure that you've got all 10 values accounted for. You don't have to count down your list. Okay, once you have all the data in there, you're going to hit stat again. So everything's going to be in this like stat world menu. This time we're going to go over to calculate, and then this first option is going to be your best friend this semester, one variable statistic. So if we just have a single set of data that we can use X to represent, this one command will give us a bunch of information. Right now it's going to give us a lot more than we need, but the other stuff we will eventually need. It should say list 1 on there. Does everybody have a list 1? Okay, you can change that to another list if you don't want to like clear data out of your calculator. If you look at the stat button, right above the stat button, it says list. So if you hit second list, you can make it list 2 or list 3, and that's whatever column it'll use to calculate data. Frequency list, you don't have to worry about that. That's only if you want data values to occur more than once, which we don't. And then calculate, we're just going to hit enter, and then it's going to give you this big list of stuff. If you scroll down, you're going to see a few more items at the bottom. A lot of it, again, we don't need right now, but we're going to look for certain symbols. So the X bar, 495.4, that's our mean that we had. And value is 10, it told us. If you scroll down to median, you can see the median is 460. It did that for us. It doesn't give you range, but it does give you the minimum and the maximum at least. So you could do a quick little subtraction calculation that's going to at least identify what that biggest and smallest numbers are. It also doesn't do mode for you, but hopefully you can just look at the numbers and figure out what the mode is. Okay, the two that take the longest, it does that for you, the median and the mean. All right, any questions in the calculator? All right, so you can use that on your Math Excel as you like. I would recommend at least doing like 1 or 2 problems by hand just to make sure you're good with it. But then after that, if you feel like you got it, you can use your calculator for sure. Okay. Next, we need to talk about outliers. So outliers are data values that are either pretty far above or pretty far below our data set. So they don't fit with our data set. For right now, we're just going to be talking about kind of, I think it's an outlier. It looks really big or really small. We will eventually, by the end of the chapter, be able to mathematically prove that we have an outlier. We're just not going to be there in this section yet. So for right now, we're just kind of guessing. These 3 pictures are what outliers could look like in different types of graphs, in a scatter plot, in a dot plot at the bottom, and then we're going to do box and whisker plots later on. If you have a really long whisker, that's going to be an outlier, likely. Okay, next slide on your paper. The table below shows sample ages of students from a class. We're going to find mean, median, and mode of the ages, and then we're going to look at why we have a discrepancy in those measures of central tendency. Okay, so mode should be the quickest. What's the mode? 20. Okay. The median is the guy in the middle. So how many do I have here? 1, 2, 3, 4, 5, 6. I have 20 numbers. Okay, so which numbers are going to be in the middle? It's an even number, so there's going to be 2 of them. Could you do it without crossing it out? Could you just count it? It's going to be, okay, so it's going to be the 10th and 11th number in the list are going to be the 2 in the middle. But then you can count it or cross out or whatever to get to it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So 21 and 22 are in the middle. They've got 8 numbers before it, 8 numbers after it, which means my median is just 21.5. Mean, we know we have 20 numbers. That's our n. We need to add them all up real quick. I got 475 for my sum. Divide by 20, 23.75. Okay, so the question is, the mode and the median are pretty close to each other. The mean's quite a bit higher. Why is the mean higher? Yeah, because we have an outlier. So if you have an outlier that's too high, it's going to pull the mean. The mean is where you're going to see that difference mostly between all of these measures. It's going to pull the mean up. If you have an outlier that's too small, it's going to pull the mean down. So if you notice that your mean is significantly different than the mode and the median, especially the median, then likely you have an outlier that's either too big or too small. And again, we'll be able to prove that it's an outlier in a little bit. If you had to pick a measure of central tendency, so one of these, and only one of these, that would best describe a typical student in the class, which one would you choose and why? Okay, so again, don't worry about whether it's mode or median or mean right now. Would 20 or 21.5 or 23.5 best describe the average or the most often occurring or the normal student that shows up to this class? What number do you think? I would probably say the 21.5. Yeah, because we have some students below that, some above that. The mode is the youngest student in the class. There's a few of them, but it's the youngest student. And then the mean, we actually only have 3 students that are older than that, including the outlier. Okay, so probably that one, I would say, best describes it with a single number. Depending on if you have an outlier or not, that answer can change. There's not necessarily one right answer that we pick for that type of question all the time. All right, and there's a graphical picture of that outlier if we would graph these data values. Okay, next slide on your paper is a weighted mean. Formula changes just a little bit. So if we have data values that each have a weight of some kind, we calculate a weighted mean. So an example of that is GPA, or how your grade in this class is calculated. Your homework is worth a certain weight, and your quizzes are, well, those are like the homework. Your tests are worth a certain weight. Your projects are worth a certain weight. So that's a weighted grade. The formula looks similar to start. So on the top, if I want to calculate X bar sample mean, we see that summation symbol, but it is the sum, if we wanted to write it in words, it's above there, the sum of the products of the entries, which are your X values, and their respective weights. So what you're going to do is you're going to multiply each data value by its respective weight. You're going to get a bunch of XWs, and then you're going to add those up. So that numerator is the sum of all of the X and W's multiplied together. Then the denominator is the sum of all of your weights. And then you divide the two numbers and you get what we call a weighted mean. So an example at the bottom, homework is worth 25%, projects are worth 20, tests are 30, final exam is worth 20. At the end of the semester, Bob has the following grades. In homework, he has a 95%, projects 82%, tests 85%, final exam 64%. What is Bob's final weighted grade? Okay, so his final weighted grade is the sum of all of his X's times their weights, his grades times the weights of each category, divided by the sum of the weights of each category. Okay, so there's a couple different ways you can write this. I'm going to write this the long way. I'm going to take each grade he has and multiply it by the homework percentage or the test percentage or the project percentage. So I'm going to say 95 is his homework grade times 0.25. Okay, plus 82 is his project grade, and that's worth 25%. I'm going to run out of room. Plus 85 is tests, and that's worth 30%. Plus 64 was his final. Oh, that wasn't good. Times 0.2. Wait for that. Okay, so that's each X times its respective weight. And then we divide by the sum of the weights, which the weights are just the category percentages, 0.25, 0.25, 0.3, and 0.2. And if it's a final grade in a class, the sum of the weights there should add to 1. So when you guys calculate your final grade in this class, likely you don't do the denominator because the final percentages add to 100%, which means you're dividing by 1, which means it doesn't change it. So that's why I usually don't see this in that calculation. Okay, so really the numerator is all we have to type in our calculator to figure out what he gets. And I got 82.55 for his final grade. Okay. All right, the next slide on your paper is another weighted mean, another way we can see this done. GPA is another example of a weighted mean. This time the weights are not going to add up to 1 at the bottom. So when you are assigned a grade, and here we have plus and minus grades as well, each letter grade has a certain GPA associated with it. So an A plus and an A are worth the same. A minus is worth a 3.7, B plus 3.3. If you don't have plus and minus grades, it's just the A, B, C, D stuff. All right, so in college semester, these were Mike's final grades. So in English Comp, which is a 3 credit hour class, he earned a B plus. In chemistry, which is a 4 credit hour class, he earned a C, so on and so forth. The number of credit hours that a class is worth is the weight of that class. If you've taken a 4 credit hour class, that was more work, more weight than a 2 credit hour class. So we count that grade 4 times instead of 2 times or whatever. The letter and the GPA associated with that is the X. Okay, so for a B plus, it would be a 3.3. So if I were going to start calculating his GPA, his weighted mean, for that first class, he earned a 3.3 on the scale because he got a B plus, and that was weighted 3. Make sense? Okay, see if you can finish it now. Include the other 4 classes, and then remember in the denominator, we're dividing by only the sum of the weights, so the sum of his credit hours. All right, answer 3.3125 is his GPA. You can double check your numerator and denominator there. Okay, how'd you do? Okay. All right, so that's how we get a GPA. Next slide. This is how you calculate a mean if you have a frequency distribution. When you have a frequency distribution, like if I see a time of 10 and frequency of 3, it just means 10 occurs 3 times. So you could write out all the data values and do the mean normally. You could just do 10 plus 10 plus 10 plus 5 11s plus 2 12s, or this is just giving you a shortcut. It's saying, and I know it's a little hard to see, that box is dark, you're going to multiply each x value, which in this case would be time, times its frequency. If I add up 3 10s, it's the same as 3 times 10, or 30, okay? So that's what this column is. It's all the x times the f's. If I add up 5 11s, it's the same as 5 times 11, 55, 24, 26, 14, and then the sum at the bottom of that column is what we're going to use in our numerator. It's the sum of all the x times f's. So 30 plus 55 plus 24 plus 26 plus 14, I get 149. Divided by the sum of all of the frequencies is your n. We've practiced that already in our previous lessons. So if I add up the frequencies, 3, 5, 2, 2, 1, I get 13. 149 divided by 13 is going to give me a sample mean of approximately 11.462 if I give it 3 decimal places. Okay. So you can do it that way, or again, you can just list out all the data values, but if we have a really large data set with a lot of repetitive numbers, this can, again, save you some time. Okay? All right, let's say we have a frequency table on your next slide that we don't actually know the individual data values. Like if we have a histogram or something like this, like these classes that we've been talking about, if I look at that first row, it's number of coffees, average number of coffees per hour, or coffees per hour that we're talking about, cappuccinos. I know that between 0 and 3 cappuccinos, there are 2 data values. I just don't know what those data values are. It could be a 1 and a 1, or a 2 and a 3, or both zeros. We don't know, but we just know there's 2 of them. So we're not actually, when we do this, going to get the exact answer. Without the raw data, you can't get the exact answer, but we can approximate it. If that's the case, you're going to use midpoints. So the midpoint of 0 and 3, if I add them up and divide by 2, I get 1.5. Okay, or the midpoint of 4 and 7, I get 5.5. And you're going to see that those just increase by 4. That's like the magic number. That's our class width here. So 9.5, 13.5, and 17.5. We're going to treat those interval midpoints like our x values. And then we have frequencies. So in the last column, it's like what we just did on the previous slide. It's just the frequencies times our x's, our x times our f's. So 2 times 3.5 gives me, or 1.5 gives me 3. I'm going to get a, what do I get here? 16.5. What is that? 72, 76. I'm doing these quick in my head. 40.5 and 35. Okay, and then the 2 sums that we need are the sum of the frequencies, which are the total coffees, cappuccinos, whatever is represented here. There are 18 of them. And the sum of all of my x values times their frequencies. X bar, we divide the 2. 201 over 18. 11 point, this one I can give an exact answer. 1/6 repeating, or you could leave it as the fraction, 201 over 18. Okay. Questions on that? Don't put your paper away. I have one more thing you're going to write on that little margin that's left. Okay. Last thing. Once we can calculate a median and a mean, we can actually look at shapes of distributions. Our most common shape of distribution this semester is going to be symmetric, or a bell-shaped distribution. What you want to be able to recognize are these 4 terms. Either the distribution is symmetric, uniform and rectangular, or interchangeable, and then we've got 2 on the next page that are skewed left and skewed right. I would recommend in that little margin you guys have left, just sketching the shape would be fine. Symmetric means it's a mirror image of itself. So it could look like this. It could look like, I don't know, this would be an example of symmetric. Okay, as long as I can draw a line down the middle and it's a mirror image on either side, we have a symmetric distribution. Also, I would note in a symmetric distribution, the mean and the median are going to be in the middle. They're going to be pretty close to each other. They might not be exact because it's data, but they're going to be really close to each other. So if you're not sure what kind of distribution you have, you can look at the mean and the median to help you figure that out. Uniform is sometimes called rectangular. You can see why it's called rectangular. Everything just has the same frequency all the way across the board. Again, in this case, the mean and the median are going to be in the middle, and they're going to be real close to one another. So if I had like a mean of 31 and a median of 31.5, it's likely one of these 2 distributions. Those are really close. The last 2, and I can flip back if you need me to, are skewed left and skewed right. So skewed left is sometimes called negatively skewed. We're going to talk in this class about tails on graphs. A tail on a graph is like an extra little, I don't know, end that goes either to the left or to the right. where the tail is located is which way the graph is skewed. I have more data values to the left, so it creates a tail to the left, and therefore we say it is skewed to the left. In this case, the mean is less than the median. So we've got like maybe some outliers or some low numbers that are pulling that mean down, and that's what's causing it to be skewed left. Skewed right is just the opposite. We say it's positively skewed. It has a tail on the right, and this time the mean is greater than the median. Okay, so if they're close together, it's going to be symmetric or uniform. If the mean is smaller, it's being pulled to the left, skewed left. If the mean is greater, it's being pulled to the right, skewed right. Okay, we just want to know those 4 terms. That's it. All right, so once you're done with that, we're all set on our 2-3 lesson. Your 2-2 Math Excel is due tomorrow night. That's your next deadline. We're in February now. 2-3 is due on Monday. Okay, so you have 1 Math Excel due tomorrow, 1 due on Monday. Okay. Any questions for me? All right, thank you for bearing with me. I know this was a little bit of a longer lesson today. Tomorrow we're going to make paper airplanes and fly down the hallway. Doesn't that sound like fun? Some days are a little more fun. Okay, 9 is my cell phone lotto winner. Nobody's. Oh, wait. Riley was going to do it. Oh. That doesn't count. All right, come back. All right. How do I do it? Just spin it until one pops out. There you go. 18. Oh, nobody won. Oh, well. Next time. All right, you can grab your phone. Thank you.